You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Complexity thinking equips agile practitioners with a lens for understanding why some problems defy traditional planning and why different approaches are necessary depending on context. Instead of assuming a universal method works everywhere, complexity frameworks guide teams in classifying situations by uncertainty, interdependence, and rate of change. This classification is not academic. It is a practical step toward choosing how to act. For example, when requirements are stable and agreement is high, detailed planning makes sense. But when the environment is volatile and stakeholder views diverge, experimentation becomes more effective than prediction. On the exam, Domain 1 mindset questions often test whether candidates can apply classification to scenario reasoning. In practice, complexity thinking ensures that methods, leadership, and risk postures adapt fluidly, preserving agility even under conditions where certainty is scarce and interactions are unpredictable. Complex adaptive systems, or CAS, describe environments made up of many independent agents interacting under local rules. These agents adapt to feedback, and their collective behaviors produce outcomes that are emergent rather than predictable. Markets, ecosystems, and organizations often behave as CAS. A small change in local interactions can ripple outward into disproportionate effects, making simple cause-effect reasoning insufficient. For instance, altering a pricing model may not only shift customer behavior but also provoke competitor responses, creating nonlinear dynamics. On the exam, CAS appears in contexts where emergent behavior defies upfront control. The agile answer usually emphasizes experimentation, feedback loops, and incremental adjustment. CAS remind practitioners that adaptation, not prediction, is the hallmark of success in complex domains. CAS classification cues help teams recognize when they are working in such environments. Indicators include heterogeneity of agents, nonlinear cause-effect relationships, tight coupling between components, and sensitivity to small changes. When these cues appear, attempts to impose rigid design upfront are likely to fail. For example, in a large enterprise integration project, dependencies across teams and legacy systems create nonlinear risk. A small misalignment can cause widespread disruption. In such contexts, safe-to-fail experiments and adaptive governance outperform detailed upfront plans. On the exam, candidates may be asked to spot signals of complexity. The correct agile response usually involves recognizing these cues and shifting to exploratory methods. Classification is about noticing the patterns that suggest traditional approaches will falter. The Stacey framework offers another way to classify work, positioning it along two dimensions: certainty of requirements and degree of stakeholder agreement. Work close to certainty and consensus falls in the simple zone, while work farther from clarity and alignment enters complicated, complex, or even chaotic zones. Stacey's insight is that the farther one moves from certainty and agreement, the less effective analysis-heavy planning becomes, and the more iteration and adaptation are required. For example, building a well-defined compliance update lies near the simple end, while designing a disruptive product in a contested market lies in the complex or chaotic zones. On the exam, Stacey often appears as a tool for reasoning about when to use iteration and feedback versus when to rely on expert analysis. The Stacey simple zone applies when requirements are stable and stakeholders largely agree. In these cases, clear practices and straightforward coordination reliably produce results. Examples include routine updates to an internal system or implementing a well-documented standard. Agile teams can still provide value here, but the work itself requires little innovation. On the exam, simple zone scenarios often test whether candidates recognize that not all work needs experimentation. The agile response usually emphasizes applying established best practices, maintaining flow, and avoiding overcomplication. The lesson is that agility does not mean abandoning efficiency in stable contexts. It means matching the approach to the problem's nature. The Stacey complicated zone features strong agreement on goals but lower certainty about the solution. These contexts benefit from expert analysis, modeling, or simulations before moving into execution. For example, designing a new data warehouse requires expert input to define structures, dependencies, and performance considerations. Once clarified, the work can proceed predictably. On the exam, complicated scenarios often involve technical uncertainty but stable alignment. The agile response usually emphasizes expert-led exploration and analysis to reduce ambiguity before delivery. Complicated work is not simple, but it is ultimately solvable with sufficient knowledge. The key distinction is that expertise and deliberate planning are useful here, even within an agile approach. The Stacey complex zone describes contexts where both requirements and agreement are shifting. In these situations, experimentation, short feedback cycles, and adaptive governance become dominant strategies. For instance, building a machine learning feature in a rapidly changing market requires iterative discovery, as user needs and technical feasibility are both uncertain. On the exam, complex zone scenarios often test whether candidates recognize the need for safe-to-fail probes rather than fixed plans. The agile response usually emphasizes experimentation, stakeholder collaboration, and flexibility. Complex work is not amenable to upfront certainty, but thrives under conditions where teams explore incrementally, sense outcomes, and adapt continually. The Stacey chaotic zone represents a collapse of clarity and order. Urgent crises, such as a critical production outage, require immediate stabilizing actions before systematic improvement can resume. In these contexts, there is no time for consensus building or exploration. Decisive intervention restores a minimum level of safety and structure. For example, when a security breach occurs, the priority is containment, not experimentation. On the exam, chaotic zone scenarios often test whether candidates can distinguish between situations requiring immediate stabilization versus adaptive learning. The agile response usually involves taking rapid, direct action to restore stability, then transitioning to systematic improvement once conditions normalize. Chaos is managed by first halting the freefall, not by analysis. The Cynefin framework provides a complementary perspective, classifying contexts into clear, complicated, complex, chaotic, and disorder. Unlike Stacey, which maps certainty and agreement, Cynefin emphasizes situational sense-making and the role of constraints. It asks, what kind of system am I in? And adjusts leadership and decision styles accordingly. For example, in clear domains, best practices suffice, while in complex domains, probing and sensing are required. On the exam, Cynefin often appears in questions about matching practices to context. The agile response usually emphasizes using sense-making to choose approaches rather than assuming one size fits all. Cynefin reinforces the principle that context dictates action, and classification is a continuous process of interpreting signals. A key feature of Cynefin is its treatment of constraints. It distinguishes between fixed constraints, governing constraints, and enabling constraints. Fixed constraints, such as safety regulations, sharply limit behavior. Governing constraints set boundaries but allow variation, such as financial budgets. Enabling constraints guide behavior while fostering adaptability, like time boxes in agile sprints. By analyzing the nature of constraints, teams can infer appropriate leadership, methods, and cadence. On the exam, constraint analysis often underpins scenarios about choosing decision styles. The agile response usually emphasizes recognizing constraint types and using them to guide approaches. This highlights that agility is not about removing constraints, but about applying them thoughtfully to shape behavior and context. The Cynefin clear domain reflects environments with stable cause-effect relationships. Here, established practices and checklists ensure predictable outcomes. For example, performing a routine backup is clear work. In the complicated domain, cause-effect relationships still exist but require expert diagnosis. A team implementing a new database architecture may need analysis and design before choosing the best practice. On the exam, these distinctions often appear in classification questions. The agile response usually emphasizes that clear work uses best practice, complicated work uses expert judgment, complex work requires probing, and chaotic work demands stabilization. Recognizing the domain determines which practices will succeed and which will fail. The Cynefin complex domain lacks predictable cause-effect relationships. Here, teams must probe with small interventions, sense the results, and respond by amplifying or dampening emerging patterns. For example, testing different user interface designs in small cohorts allows patterns of preference to emerge. The chaotic domain, by contrast, lacks even perceivable constraints, requiring immediate action to create stability. For instance, in a disaster recovery scenario, the first priority is to restore safety before learning can occur. On the exam, Cynefin domains often appear in scenarios about uncertainty. The agile response usually emphasizes probing and sense-making in complex work and decisive action in chaos. These distinctions highlight that agility is situational, not prescriptive. Comparing Stacey and Cynefin reveals that they offer complementary lenses. Stacey maps certainty and agreement, showing when iterative exploration is needed. Cynefin focuses on sense-making and constraint types, guiding leadership styles. Both frameworks converge on similar guidance. Stable contexts support best practices, complicated contexts require expertise, complex contexts demand experimentation, and chaotic contexts call for rapid stabilization. On the exam, comparison questions often test whether candidates understand these overlaps. The agile response usually emphasizes that multiple frameworks can enrich classification, and the key is applying whichever lens best clarifies the current situation. Classification is not a one-time decision, but an ongoing act of sense-making. Practical classification workflows rely on signals such as variability, rate of change, dependency density, and stakeholder alignment. Teams gather evidence through observation, metrics, and dialogue to decide which domain best describes the current context. For example, a backlog with stable items and aligned stakeholders may sit in the complicated domain, while one with contested priorities and high volatility sits in the complex domain. Importantly, classifications must be revisited as evidence evolves. On the exam, candidates may encounter scenarios where context shifts mid-project. The agile answer usually emphasizes reclassification and adaptation, ensuring that tactics match current reality rather than outdated assumptions. Classification is a living process, not a static label. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Classification frameworks are not theoretical exercises. They directly guide approach selection. When work is classified as simple, standardized practices and clear checklists provide reliable results. In complicated domains, expert analysis, modeling, and review reduce ambiguity before execution. Complex work benefits most from experimentation, safe-to-fail probes, and iterative sense-making. Chaotic situations demand immediate stabilization before any structured improvement can begin. For example, a compliance update can be handled through standard procedures, while launching a novel product in an evolving market requires iterative trials and feedback loops. On the exam, scenarios often test whether candidates can map classification to approach. The agile answer usually emphasizes that method selection follows context, not preference. Misclassification leads to waste or unmanaged risk, while accurate classification links action to reality. A simple compliance update provides a useful contrast to a complex innovation effort. Updating a reporting template for regulatory requirements is clear work. The rules are stable, the outcomes are predictable, and standard processes ensure success. By contrast, designing a machine learning feature in a shifting market is complex work. Requirements evolve as discovery unfolds, and stakeholder alignment may be contested. Planning horizons differ dramatically. In the compliance example, upfront analysis suffices. In the innovation example, Iterative learning with small probes is essential. On the exam, candidates may be tested on whether they can distinguish these classifications. The correct agile response usually emphasizes scaling planning effort to the nature of the work. Complexity thinking helps practitioners avoid applying the wrong tool for the job. Social complexity can elevate technical challenges into the complex domain. Even when the technical solution is straightforward, competing incentives, dispersed authority, or low trust may make agreement elusive. For instance, implementing a simple process change across multiple departments may become complex if stakeholders disagree on priorities. In such cases, facilitation, incremental proof, and relationship building become as important as technical execution. On the exam, scenarios often test whether candidates recognize that social dynamics can move problems into the complex domain. The agile answer usually emphasizes the need for incremental delivery, transparent collaboration, and trust building in addition to technical work. Complexity is not only about technology, it is often about people. An uncertainty taxonomy helps teams decide how to respond to gaps in knowledge. Reducible uncertainty arises from missing information that can be addressed through research, spikes, or expert consultation. For example, uncertainty about which API version to use can be resolved with analysis. Irreducible variability, by contrast, stems from inherent randomness and must be managed with buffers, smaller batches, and adaptability. For instance, unpredictable response times under real-world load may only be stabilized through monitoring and resilience patterns. On the exam, candidates may encounter scenarios where uncertainty must be classified. The agile response usually emphasizes research for reducible uncertainty and adaptive mechanisms for irreducible variability. Distinguishing between the two prevents wasted effort and aligns management with reality. Dependency and coupling analysis sheds light on how integration, legacy systems, and vendor interfaces raise complexity. The more tightly coupled components are, the greater the risk that a small change creates widespread disruption. For example, a payment system dependent on multiple vendors and legacy databases may shift a problem from complicated into complex. Teams use dependency mapping to inform slicing strategies and sequencing choices, reducing risk by tackling integration points incrementally. On the exam, dependency scenarios often test whether candidates can see how coupling affects classification. The agile answer usually emphasizes decoupling work where possible and sequencing increments to validate integration early. Dependencies drive complexity, and managing them transparently is essential for flow. Evidence collection supports classification by grounding judgments in observable patterns. Teams can examine cycle time variance, defect clustering, and rework frequency to identify whether a context is truly complex. For example, if predictions repeatedly fail and rework rates are high, the domain is likely complex rather than complicated. Using data corroborates or challenges assumptions about classification, preventing teams from relying solely on intuition. On the exam, evidence-based scenarios often test whether candidates understand that classification is iterative. The agile response usually emphasizes collecting data to validate or revise domain judgments. Evidence ensures that classification reflects reality rather than aspiration, sustaining agility through transparency and feedback. Reclassification cadence ensures that classifications remain accurate as contexts evolve. Teams should schedule periodic checks and establish explicit triggers that prompt reclassification. For instance, if predictions consistently fail, if contention among stakeholders increases, or if cycle time variance widens, the context may have shifted from complicated to complex. Reclassification protects teams from treating yesterday's conditions as today's reality. On the exam, reclassification scenarios often test whether candidates understand that classification is dynamic. The agile answer usually emphasizes adjusting methods when signals indicate a domain shift. Reclassification embodies empiricism, adapt not only product and process, but also the way work itself is understood. Team agreements anchor classification in daily practice. For example, In complicated work, backlog items may require detailed acceptance criteria and modeling before development. In complex work, backlog items may be looser, emphasizing hypotheses and learning objectives instead. By linking classification to definition of ready thresholds, teams avoid overspecification in uncertain contexts and underspecification in predictable ones. On the exam, scenarios often test whether candidates understand how classification affects backlog refinement. The agile response usually emphasizes tailoring readiness and documentation to the domain. Agreements ensure that classification is not abstract but visible in everyday choices. Risk posture varies by domain. In complex contexts, teams limit blast radius, use probes, and amplify or dampen patterns based on results. In complicated contexts, they invest in analysis and simulation before committing. In chaotic contexts, they act immediately to stabilize. For example, a chaotic outage may require shutting down systems to restore control before analysis can begin. On the exam, scenarios often test whether candidates can match risk posture to domain. The agile response usually emphasizes proportional risk management aligned to uncertainty. Agility does not eliminate risk, it manages it differently depending on context, balancing exploration with protection. Leadership stance must also shift with classification. In clear work, directive leadership ensures consistency and efficiency. In complicated contexts, leaders rely on expert judgment. In complex environments, leadership becomes enabling and sense-making, empowering frontline insights. In chaos, decisive command restores stability. For example, a leader managing a crisis may act directly, but once stability returns, they step back to facilitate learning. On the exam, leadership scenarios often test whether candidates can adapt style to domain. The agile response usually emphasizes flexible stances, recognizing that no single leadership mode suffices across all contexts. Agility requires leaders to read the environment and adjust behavior accordingly. Measurement approaches vary across domains. In clear work, conformance indicators like defect counts and process adherence measure success. In complicated work, expert validation and accuracy metrics dominate. In complex domains, teams track pattern detection, hypothesis validation, and engagement with probes. For instance, measuring the adoption rate of experimental features provides insight in complex contexts. On the exam, scenarios about metrics often test whether candidates understand that measurement must adapt to domain. The agile response usually emphasizes shifting measurement focus from stability to learning as complexity increases. This reinforces the principle that metrics serve context, not ideology. Communication style should also align with classification. In clear work, instructions and checklists suffice. In complicated work, structured reports and expert briefings are necessary. In complex contexts, narrative sense-making and framing of uncertainty are more effective as they help stakeholders understand evolving patterns. For example, sharing stories of user behavior can illustrate emerging trends better than static charts. On the exam, communication scenarios often test whether candidates can adjust their style. The agile answer usually emphasizes context-sensitive communication, clarity for stable domains, storytelling for complex ones. Agility requires leaders and teams to tailor communication to how uncertainty is best understood. Failure modes often arise from misclassification. Overplanning in complex work wastes effort and delays feedback, while underspecifying in complicated work creates defects and rework. For example, treating a novel AI project as complicated may lead to extensive modeling that produces little real-world learning. Conversely, treating a complex medical integration as simple may create compliance failures. On the exam, misclassification scenarios often test whether candidates can spot the risk of applying the wrong approach. The agile response usually emphasizes avoiding waste and unmanaged risk by matching methods to domain. Failure modes are not inevitable but stem from mismatched strategies. Documentation practices remain lightweight but must be domain appropriate. In clear contexts, minimal documentation suffices, because practices are stable and well understood. In complicated domains, structured analysis records may be needed to capture expert reasoning. In complex domains, documentation often records assumptions, probes, and observed outcomes to support transparency and learning. For example, logging hypotheses and results in a repository allows teams to revisit and refine classification decisions. On the exam, documentation scenarios often test whether candidates understand this nuance. The agile response usually emphasizes right-sized documentation that supports sense-making without burdening flow. Agile documentation is never about volume. It is about purpose. In conclusion, complexity classification enables agile teams to match methods, leadership, and risk postures to the reality of their work. CAS highlights signals of emergent, unpredictable behavior. Stacey maps certainty and agreement, showing when exploration is necessary. Cynefin emphasizes sense-making and constraints, offering a dynamic lens for choosing approaches. Together, these frameworks guide practitioners in recognizing when to apply standard practices, when to consult experts, when to experiment, and when to stabilize urgently. On the exam, candidates will be tested on their ability to classify scenarios and choose actions aligned with principles. In practice, classification protects teams from waste and unmanaged risk, ensuring that agility adapts as reality changes. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.